In the realm of fashion's hasty chase, fast fashion's trend a reckless race. Single-use plastic a deadly trace, in this modern world we must embrace. A garment stitched with fleeting grace, made for a mermaid not to embrace. Tossed aside without a second's grace in the landfill's dark and endless space. Single-use plastic convenience's face wraps our lives in the cold embrace. A fleeting purpose, a toxic case, choking oceans in a watery maze. In pursuit of style, we often misplace the value of our planet, its fragile grace. Fast fashion's grip we must efface and choose a path of sustainable base. Let's seek our fashion with a slower pace, where timeless designs find their place. Materials reused we can retrace, a future where beauty and earth's health interlace. Reduce, reuse, recycle are embraced to heal the wounds of the plastic chase. Slow fashion's beauty, a lasting grace in a world where sustainability we embrace. Bioplastics. Better future, better plastic. The fast fashion industry is known to create clothing quickly based on current trends in the fashion industry. They are known to use cheap, low quality textiles to make cheap, trendy clothing in the general public, whom generally wear these items only a few times before disposing these items, which ultimately end up in landfill. Many of the clothing are made from synthetic fibers which cannot or take centuries to decompose and therefore have no viable ways of removing it from the environment. The most common of these synthetic textiles is polyester, accounting for nearly 52% of all textile used in the world, as shown in the pie graph. This petroleum based fiber is harmful for humans, wildlife, and the environment, releasing toxins during its manufacturing process, and even washing the fabric can release microplastics into the waterways. To address this issue, I have developed a new bioplastic textile that is environmentally friendly and can be biodegradable and even dissolve in boiling water. It can be cut into a long string that can be used as a yarn to knit or weave into a fabric. It can also be put into molds to create the shape of the garment without needing to be cut or sewn together. Petroleum based polyester is not biodegradable and contributes to pollution around the world as it can remain in the Earth's ecosystem for centuries. The extraction processes to make ethylene polyester introduce toxins into the environment as they produce harmful synthetic byproducts from the dyes, and washing these polyester fabrics release tiny synthetic microfibers into the water supply, where treatment processes that are used by the manufacturers go into the surrounding environment and poison these areas. Even recycled polyester is rarely made from fibers of recycled clothing. This is due to garments being made of a blend of materials: elastic, yarn, metal, zips, plastic buttons, where about 13% of clothes were being recycled and unwanted clothing were discarded in environmentally harmful ways. This recycled polyester that is often advertised by fast fashion are usually made from old plastic, such as plastic bottles, not the plastic of fast fashion. In 2020, 99% of recycled polyester was sourced from PET bottles, and less than 0.5% of the global fiber market came from pre and post consumer recycled textiles. Polyester is a synthetic fiber that is usually derived from petroleum. It is one of the most common and popular textiles in the world and is used readily in the fashion industry, specifically in fast fashion, as it is cheap, strong, and durable, where this durability poses a problem as it is not biodegradable. It is wrinkle resistant and easy to dye, where colors will remain bright and will not bleed like cotton and silk. It is highly stain resistant, making it easy to clean, and it is also cheaper than other synthetic or natural fibers. Polyester also has water resistant properties but is not 100% waterproof. Small change, big impact. To address this issue, I have come up with a bioplastic as an alternative to synthetic textiles, particularly petroleum based polyester. I have produced a bioplastic textile that can be dissolved in boiling water and is fully biodegradable. It does not release harmful toxins during manufacturing and does not release microplastics into the waterways. This bioplastic is made mainly from gelatin, which is the byproduct of animals, and it's inexpensive to make, resulting in a textile that is still flexible, durable, and even water resistant, but is also environmentally friendly. Here are examples of my bioplastic used in clothing. Anki Damaski, a young fashion designer from the German city of Hanover, has developed a fabric called Q-Milk, made from high concentrations of the milk protein casein. The casein is extracted from dried milk powder and then heated up with other natural ingredients where the fiber comes out in strands and is spun into yarn. These fibers are colorless, environmentally friendly, biodegradable, and have antibacterial and anti-allergic properties. Low resources and energy are required for production, resulting in zero waste, and CO2 emissions are very small. It is interesting to know that other proteins from animals, not just collagen, can be also made into bioplastics. Limitations of bioplastic I created is that there is a high chance of the bioplastic melting in temperatures 40 Celsius and above. So it would be advisable not to wear this textile when temperatures are over 35 Celsius. This could also be addressed by conducting further research of the possibilities of my bioplastic being combined with other bioplastics that have a much higher melting point, ultimately making my bioplastic's melting point increase. Also, there are some ethical issues with using gelatin as it is made from the byproducts of animals. Some individuals do not want to use these made from things made from animals as they assume the animals is being harmed in the manufacturing process. This could be avoided by only using gelatin made from the byproducts of animals and making sure no animals are harmed in the process and letting customers know this. It would be interesting to see a finer string made from this bioplastic to see how thin the resulting fabric could be created. This could be done in an extrusion machine, and after the bioplastic has gone through this and made into different sizes, these fibers could be tested on durability, aiming to find the thinnest strand before it becomes too brittle to make a textile from.